Algebra 1. Today we are going to continue moving through 8.2. In your books, that's on page 481. And we will be going over two different types of practice problems. Before we do that though, I want to stop and review a concept that you learned many years ago in elementary school. And we want to make sure we're up on that before we dive into the harder material. So in your books, page 481, and note handout that I posted on RenWeb, or at least some paper and pencil to take notes. The first thing that I want to review is talk about a greatest common factor. Whenever we see GCF, that's the common abbreviation for greatest common factor. Whenever we see the word factor, we need to know that those are pieces that are being multiplied together to form a bigger piece. Almost think of it as building blocks. So when we want to get the greatest common factor, we want to get the largest number of whatever the terms are that we're given. So before we dive into that though, I want to review prime factorization. Let me write that up here and abbreviate. Okay, so this is a blast from the past. It might be taking you back to elementary school. And if I wanted to ask you what the prime factorization of 810 is, I want to demonstrate the method or the thinking behind that so that when we dive into variables and powers, we can still do the same thing. So whenever we want to break down a number into prime factorization, it needs to be all of the numbers that multiply together to give me a bigger number, but I want all of them in their lowest form, in all of their prime numbers, meaning prime numbers are only divisible by itself in 1. So at this point, 810 is not a prime number. So the method that you probably first learned was using a factor tree. So if I break 810 into 81 and 10, those are two factors that multiply together to give me 810. But neither of those are actually prime numbers, so I'm not done. So I need to keep breaking it down until I get there. So I see that 10 breaks down to 2 and 5. Those are both prime numbers. So at this point, that part is done, but I still need to deal with 81. 81 breaks down to 9 and 9. Well, neither of those are prime numbers. I have to keep going. So I get 3, 3, 3, and 3. And it's helpful if I want to go ahead and circle the prime numbers. So the prime factorization of 810 is actually 2 times 3 times 3 times 3 times 5. This skill is going to be helpful as we move into finding the greatest common factor, which again, I'm going to demonstrate on a very basic level with numbers. So if I had 63 and 14 and I wanted to know the greatest common factor, remember I'm thinking of the largest number that goes into both of them. Now, most of you can probably just look at those two numbers and tell me what it is. But when we start adding in variables and exponents, it might be a little harder. So I'm going to demonstrate again. If I need to find the greatest common factor of these two numbers, I'm going to list the prime factorization of both of them. Now in my head, I know that 63 is 9 times 7, so it's a 3 times 3 times 7. 14, if I break that down into just prime numbers, is 2 times 7. So I look at what they have in common. Greatest common factor, and I know they each have a 7 in it. The 3 doesn't work because they don't both have a 3, and a 2 doesn't work because they both don't have a 2. So my greatest common factor of those two numbers is 7. That means that's the largest number that is divisible into either of those. Okay, well let's take that skill and apply it to polynomials. Okay. The first type of problem that you will be asked in this section is like, is like problem 2 in your book. And it's also right here. I want to know the greatest common factor of this trinomial, 3 terms, 5x cubed plus 25x squared plus 45x. And I'm going to do it the same way. Now, for a lot of you, you might be able to just look at these terms and list the greatest common factor. Great. If you're having trouble with this, I'm going to show you a method to get the right answer every time. So I'm going to list out the factorization of each of these terms. And so if I have 5x cubed, I know that that equals 5, because 5 is a prime number, times x times x times x. If I were to take that number and expand it to every factor involved, that's what it would look like. 25x squared would be 5 times 5, if I break down 25 to its prime factorization, times x times x. 45x would be 3 times 3 times 5 times x. Then I look at all three of these and I take all of the chunks that they have in common. And so each of them have 1 5. There isn't enough to take 2 5s or any of the 3s because these don't have 3s. Then I'm going to see that they all have an x in common. And there's not enough x's to take any more. I can only take 1. So my greatest common factor of all of these terms is 5x. When it comes to variables with powers, one of the shortcuts is you take the variable with the lowest power. So if I look at all three of these, the lowest power is my x. That's the only one that I can take from each of it. If I'm having trouble, do the prime factorization of each of the terms and take what they have in common. Okay, so there's my answer, 5x. That's the greatest factor that divides into each of those terms. What I want you to do is try the practice problem, pause the video, and attack this one. And this is the got it problem from problem 2 in your book. So greatest factor, common factor, of 3x to the 4th minus 9x squared minus 12x. Pause the video, try that one, and then we'll go over it together. Okay, I'm not going to break down each of these pieces. I'm going to just talk you through how I'm pulling it out in my head. So if I look at my numbers, 3, 9, and 12, the greatest number that goes into all three of those is a 3. 3 can go into that, that, and that. Another hint for when you're dealing with the greatest common factor of a number, it is never going to be greater than the smallest number. Just like in our first example, my greatest common factor couldn't be greater than 5 because it wouldn't divide evenly into 5. Same goes here. It would never be greater than 3. And in this case, it is 3. So I can divide 3 evenly into each of those numbers. Then I look at my x's. I have the power of 4, power of 2, and the power of 1. And remember my hint from the practice problem, I take the lowest power. So my greatest common factor of those three terms is 3x. Okay, I'm gonna go ahead and clear my board and take a minute or two to write out our next practice problem, or our next problem and the practice problem that goes with it. Because now we're going to move on to actually factoring out the greatest common factor. So in this first type of problem, you were asked just to list the greatest common factor. Well, we're going to take that one step further and actually factor it out. Okay, so I just wrote the polynomials here. In your book and on the note handout, it actually forms the whole question. The question is saying, what is the factored form of this polynomial? Well, when I want the factored form, I want to pull out the greatest common factor and write it as a multiplication problem. So it's like we are doing the opposite of the distribution problems we did yesterday. Factoring is the opposite of distribution, and we use division in this. Instead of like with distribution, we use multiplication. Factoring, we do the opposite and we divide out. So the first thing that I want to do, if I want to write the factored form, I will figure out what the greatest common factor is. And in this case, looking at my numbers, again, if you are not able to look at the numbers and just think through it mentally, you need to be working through the prime factorization to get this final answer as your greatest common factor. If I look at this, I have 4, 24, and 8. I know that it will never be greater than my smallest number. But if I look at 4, I see that 4 goes into 4, goes into 24, and it goes into 8. So I know my greatest common factor is going to have a 4 in it. Then I look at my x's, and I take the lowest power. In this case, this x to the first power is the lowest one. So once I find the greatest common factor, I'm actually going to go ahead and erase this. My answer is going to have my greatest common factor outside a parentheses, a quantity. And what is inside is going to be what happens when I divide each of these terms by that greatest common factor. Remember, factoring is division. So it's like I'm pulling out something they have in common. So when I divide this first term by 4x, well, that cancels. And then I use my power rules. 5 minus 1 gives me x to the 4th. Then I go to my second term. Still going to remain subtraction. Then I divide. 24 divided by 4 gives me 6. X cubed divided by x, I'm going to subtract my powers and get x squared. I move on to the third term. Still going to remain addition because I don't have a negative number out front. 8 divided by 4 is 2, and my x's cancel out. So that leaves me with just 2. So once I factored or divided out by that greatest common factor, my answer should look like a multiplication problem with my greatest common factor on the outside of parentheses that still, if I had 3 terms to begin with, I should still have 3 terms inside. Now, how would I check to see if this is correct? Well, I would check it by doing the opposite operation. In this case, I would distribute mentally this 4x, going back to yesterday's lesson. And if I wanted to double check that, I would get 4x to the 5th, that's what I had there, minus 24x cubed, which is what I had to begin with, and then 8x, and that's what I had to begin with. So always check your work. I want you to pause the video and try the second problem, which is in your note handout, as well as it's the Got It problem under problem 3 in your book. Okay, pause the video and go for that. Okay, here we are. We're going to do the same thing. I'm not going to take as much time to talk us through. I am going to first find my greatest common factor. So if I look at this and I look at these numbers, I know it's never going to be greater than 9, but 9 does not go evenly into 15 or 12, so 9 is not an option. The only other factor of 9 is 3 and 1. 3 does go into each of those, so I know my greatest common factor is going to have a 3 in it. Then I need to figure out how many x's can I take out of each of these terms. X to the 6th, x to the 4th, x squared. I always take the lowest. So I know my common factor is x squared. Factoring is division, so I need to divide each of these terms by that greatest common factor. And if you can do this mentally, awesome. If you can't, be writing out the division problem on your paper. 9 divided by 3 is 3. X to the 6th divided by x squared. I'm going to subtract those powers, leaving me x to the 4th. Plus 15 divided by 3 is 5. 4 minus 2 is 2. Plus 12 divided by 3 is 4. X squared divided by x squared. We know they cancel each other out. Or if I had to think through my power rules, 2 minus 2 is 0. X to the 0, we know that's 1. So my final answer is 3x squared times the quantity 3x to the 4th plus 5x squared plus 4. And if I wanted to check it, I would distribute that back in mentally and make sure I ended up where I started. Okay, so that concludes today's lesson. What I want to point out to you though, in the book, I did not take the time to go over problem 4 in your book, and that's on page, let's see, 482. Whenever you go into Khan Academy, some of the questions that they're going to ask in the lessons that I assign are going to have a geometry spin to it. And so I want you to read through problem 4 on your own to know how to attack those in Khan Academy. The same skills are involved, but you just have to be thinking through geometry, finding area, or I think they're all going to be area problems actually. So how to work backwards through that using polynomials. Okay, so you have suggested book problems. They're written in the note handout and on RenWeb. And you have 2 Khan Academy assignments again today. And they correspond with the 2 different skills that we went over today. First, just finding the greatest common factor, then actually giving me the factored form. So be comfortable with the difference in those 2 questions. You will get that way by going over the suggested book problems. Okay, that's it for today, and I'll see you tomorrow.